Greetings, the Astro 30 here yet again with another kit to build. Let's have a look, shall we? Okay, this is the speaker protector kit for the classic D Class D amplifier that I previously presented in two parts already. Now, this protector on its own will not protect any other amplifier but that Class D module, because half the speaker protector circuitry or amplifier protector circuitry is on the amplifier boards. This is basically just the relay driver. So this will give a on-off mute, because I did notice that there is a strange noise sometimes coming out the speaker when you first power up the Class D. It's like a little squeak. So yeah, that's going to eliminate that. Now this came from not JCar Electronics directly off eBay, but someone else. And it's already been opened because the staple's already missing, and this was all cockeyed like that in the packaging. That's how I received it. So this has been opened, but I've checked, all the parts are there, the instruction manual's there, PCB, the most important thing, is there. So yeah, he had two of these for sale, so I'm not sure why he had two of them. Maybe he was going to use them for something and never did. So I decided to sell them. So we'll open the packaging here, and that's the instructions. There's our bag of parts here. We can see that this is this polystyrene here for the octacouplers is starting to deteriorate inside the bag. That's pretty bad. But all the parts are there. Nothing has been opened. So it should be a pretty simple matter of just putting the parts in the PCB. Speaking of which, this is the PCB, which doesn't look as high quality as they normally do, but yeah, it is what it is. Now, with this LED for the protect here, I plan to probably mount that to the front panel, so I would want to put in a little socket, but I don't know if those holes are going to be big enough. But if you look at the copper traces, they're fairly thick there. So I'm just going to find a connector. So I've got a two-way connector. I want to just make sure that that's actually going to fit through the holes. Well, it's tight, but it will fit. I might have to drill. Or if I actually work that in, it goes in. Yeah, that'll work. So now that that's in there, it's tight, yes, but I'm going to leave that there. It's fine. Just got to remember my anode is on the left of the socket there. But that's what I would do to mount that to a front panel. And I can actually test that because I do actually have a lead made up. So anyhow, that's the board. Uses two optocouplers, which basically come off of the MOSFET driver on the power amplifier boards respectively on each channel. And when that turns on, the relay turns off, and that's the whole entire point. So as I said, this is basically just a relay driver. So now we'll take a look at my enormous penis. No, I've got to stop saying that. We're going to take a look at the instruction manual, which is pretty much the same as what's already described in the Class D module kit. So if we look at the schematic here, we've got two optocoupler inputs. So when this LED turns on, that biases this transistor on, which basically brings the ground reference up to the gate of this MOSFET over here. The relay driver itself, which is an STP16NE NF06. I did have problems trying to find that one specifically. There is a different version of that, but this is the one I did actually find, was an STP16NF06. So that can also be used in substitution for that. That's fine. So basically what happens when one of these grounds is brought up via the optocoupler, it'll basically steal the gate drive current, bringing that down to earth or ground, because off the positive rail, which is the B plus line here, we've got a 100k resistor. Also goes through a 1k resistor over here, so we'll call it 101k just for argument's sake. That 1k is just to separate the optocouplers from the MOSFET over here. And this is our RC part of the network, which is a 47 microfarad, so that should give us a delay with 147, roughly 2 seconds delay before this transistor turns on. And basically when the optocoupler brings the ground up, or brings this 1k resistor low, it steals the gate drive current here, and that relay drops out. So that's the whole entire circuit. They've got a little table over here for if you're using different voltages. Now, I'll be using the 50 volt voltage in the end. So R11 needs to be an 820 ohm 5 watt. That's the dropper resistor for R11 over here, and I can guarantee you that's the only resistor they've supplied. And a 4K7 1 watt for R12, which is which is the dropping resistor for this zener diode. So it's normally a 4K7 1 watt, but the lower the voltage you go, you can go back to a 1/4 watt just fine. So they have supplied a 4.7K 1 watt and an 820 ohm 5 watt resistor in this bag of components here. There's also a 330 ohm there, 1 watt. Not sure what that's for offhand. It doesn't look like it's anywhere. Oh, well, that's interesting. They have actually given us, for 35 volt, they say 330 ohm 1 watt. They have given us a 33 ohm 1 watt. Okay. And you need a 22 ohm half watt if you're going at 25 volt. And yeah, I reckon that'll be in there somewhere. And so we're going to end up with resistors over, because they have actually supplied the different resistors for these different voltages, which is nice. So this circuit is not going to take that long to assemble. I average probably about 15 minutes. So I'm going to start with the connectors, the IC sockets for the optocouplers, then the low profile stuff like the resistors and diodes. Finally I'll mount the larger resistors, the STP16NF06, and then finally the relay. So let's get cracking. Okay, and that's the board assembled. I'm just putting some standoffs in. I'm not using the nylon ones that it came with. There's no grounding on this board anyway, so there's no reason why you can't use metal ones. In fact, actually metal ones you can get a little bit tighter anyway without stripping them. Nylon tends to strip very easily. That only took about 15, 17 odd minutes, something along that line. Not very long at all. It was very easy to assemble. The only difficult part was soldering in that relay because the holes were exceptionally large for the pins. No idea why they were that large. I just threw the pliers across the room. But yeah, you get that. So now I'm just going to gee, that connector's a bit crooked. Look at that. That's pretty crap. Yeah, let's see if I can fix that. Oops, I just bent that resistor. Well, that IC socket's also crooked as well. And it shouldn't hurt the optocoupler doing this, but yeah, it's a bit straighter now. Okay, anyway, back to what I was doing, which was tightening these. Already done. Yeah. This one. Okay, so I'm ready to test this module, but first I've got to put some fly leads in the connectors. Well, actually, only on the +0 voltage in. I don't really need to have any on the output there because they're not going to be used for anything at this stage anyway. So I'll just grab myself a couple of offcuts of component lead here and I'll shove them in the connector and give me somewhere to connect my test points. So all I'm going to do is connect up the power supply kit, the two transformers. That gives me, I think it was about 42 volt, something like that, which should just be in the ballpark for these values of resistors that are in here to work still correctly. So I'll do that, and I'm going to hook up an LED to this connector here from the fly leads that I actually already have made up for something else. Right, so the LED is now connected, so that should light up when it's in protect mode. So now all I have to do is, well, pop you on the floor, hook up all the other accessories to make this thing work, and yeah, we'll see what happens. Now to test this, all we do is we basically bring a 9-volt battery into this positive negative connector on each optocoupler and see if the relay drops out. If it does, the circuit is working. So we'll be using a 9-volt battery. But somehow I've got to try and get it in there. I don't have another connector made up to do that. So that's going to be interesting. But I'll figure out something. Okay, so before I move on to the speaker protector module of this amplifier kit, I have completed the power supply. I've added the bleed resistors and LEDs here for the high side. I've also included the regulators, bridge rectifier, 2 output filters for the plus-minus 15 volt rail. Now, I did have some 2200 microfarad capacitors at 50 volt each in here. They didn't fit. I couldn't get the diodes in and I couldn't get the regulators in. It calls for 25 volt ones, so I'll have to replace them with 25 volt ones at a later date before I hook it to AC. In this test, I'm going to hook it to DC. So I've got my bench power supply set to around about 18.7 volt. which is roughly close to what 15 volt AC is going to be after DC rectification. Got the multimeter there in the background set to the volt scale so I can measure the output voltage. So now I'm going to turn it on and hopefully nothing goes off with a bang, because I am using a Chinesium LM7915 regulator IC here, so we'll turn it on. Everything seems alright. So go from -15 to 0. We have 15 volt there, and on the positive side we also have 15 volt. They're the wrong way rounds because I've got these the wrong way around. Here we go, positive 15 volt that way, negative 15 volt that way. Beautiful. We should also have roughly the 18 volt coming out of here. That's the 0-20 volt rail. Yeah, it's close to 20 volt. And we should have both the plus minus 18 volt DC rails present here at the 30 volt AC output. Which we do, we got 37. So if this was using a proper transformer, we would have roughly 30 volt there, AC. Of course I'm measuring it in DC because, well, I'm powering it with DC. Now we'll notice with these regulators that they're actually screwed to the board. Now I've got two M3 screws, 5mm long, or 6mm, whatever they are, with nuts on the bottom, torqued up to the bottom of the PCB. Now you want to torque these screws and nuts tight before soldering the legs, or else you will stress the device. And I'm just having a feel of the ICs, not going into a load. They're getting slightly warm, but neither is getting any hotter than the other, so even though that one's a Chinesium one, it's working okay. It certainly is producing negative 15 volt anyway. Right, so that's the power supply tested on the low side, apart from putting in correct capacitors here. As I say, I'll do that before it gets powered from a transformer. Okay, so I got it all hooked up. Made sure all the connections are connected right. Got the bridge rectifier hooked up correctly to the positive input from the positive of the rectifier, and the negative of the rectifier is connected to the negative in, and I've put two capacitors here now. So all we need to do now is, the first part of testing is we need to check the voltage across the 15 volt zener diode, which is ZD7 down in here. That should be close to 15 volt across it. So I just have to maneuver myself around here and plug it in. Hopefully nothing goes bang, so we'll soon find out. The relay should come on too after 2 seconds, so here we go. There we go. So we should have about 14.7 across the zener. So that circuit's working. Transformers are buzzing. So now to test the speaker protector, we need to bring the 9 volt battery across it. So the easiest way I'm going to do that is there's a 1K resistor on the board, either end here, so I can just connect one lead to one end of the resistor to the negative of my battery, and then touch the positive of the battery if I can. There we go. That's working fine. So I'll test the other side. Same thing. Positives are both the same way around on this by the look of things. If not, I'm just going to short the battery. So here we go. Well, that's interesting. That side doesn't seem to work. That could be because I'm on the wrong end of the resistor. Let's try that again. don't want to come into contact with the power supply if I can avoid it. Well, that one doesn't appear to work. Let me just have a quick look, get this to work. Well, that side doesn't do anything. I could have inadvertently just damaged that optocoupler. I hope not, because I think I connected that wrong. So that side doesn't work. Okay, I might have to go out and buy another optocoupler. Not that I wanted to, but yeah, that's what happens. So I'll just double check that that other channel is working. If I can sort of like get in there, that'd be nice. Yeah. Okay. Yep, light comes on and all. It's just that this one, shamefully, doesn't work. And this one's not working at all. Okay, so I've got a dead optocoupler. So yeah, that means a trip out to the electronics store to see if I can find a new one. But all in all, it does work. This is a fairly common optocoupler here. It's only a 4N28. So hopefully JCar have a 4N28. But yeah, I reckon that this optocoupler is dead. But we can verify that unplugging the power supply, and we'll notice the relay doesn't drop out instantly. So keep that in mind. Now it does. Now it has. So I want to carefully play with my penis. Now I want to carefully find a screwdriver wherever that's gone. It seems to have buggered off. Ah, dear, oh dear. Right there. I'll take out the suspect optocoupler. Did that one there. Didn't miss any pins. And I will swap it over. Ooh, for this one, I really need an IC removal tool. I don't have one. I mean, I knew I was going to do this today, so I should have gone out and bought a couple of optocouplers just in case I blew one up. And I think inadvertently I have. But that's just what happens. Right, I've swapped the optocouplers around. Well, I've put the known good one in the other side. So we turn that on. That was awfully quick. But that's coming because the filter caps haven't fully discharged. So I'll hook up my negative lead. And I'll touch the positive to the terminal. Yeah, see, it works. So this optocoupler is definitely dead. So that was because I put the negative and the positive directly into it. There's supposed to be a 1K dropper resistor on the cathode, and basically blew the LED. So yeah, that's how sensitive they are. Now if it's a different version like an 4N26 or something, it should still work. Anyway, what I'm going to do is I'm going to unplug this, and I'm going to head off to the electronics store, and I'm going to go buy a couple of new optocouplers just to, you know, have a couple on hand, and yeah, we'll come right back with testing. Right, well, I've got some 4N25 optocouplers, and I just looked up what the difference between the 4N25 and the 4N28 are. Not much. The only difference is the current transfer ratio in DC between the two. One's slightly higher than the other. It's really nothing in it, so these should work fine in the circuit. So I'm going to replace both of those ICs with those ones because, well, they're white and it will be matching. Okay, so I have to do the test yet again, but this time I'll be careful to get the dropping resistor into the circuit, so I'm not going to blow the arse off the optocoupler. I don't see any real great big problems with this. So now, just touch the battery positive. Yep, that worked fine. Just want to hold that down. Yep, that channel's working fine. And now for the other one, just to make sure that that one's working. Yep, apparently. Yes, it is. Can't quite get in there. Perfect. So that's doing its job. I can't see any adverse effects from using the 4N25s in places of 4N28s. Yeah, it is what it is. We'll soon find out over time. But yeah, the circuit's working. I would hook it up to the power amp, but I don't have any way of hooking up these inputs. So unless I make the cables up, which I don't want to do. So basically we'll leave that there for now, and I'll come back and revisit this later once this is mounted into a chassis with both power amps. I still haven't built the other power amp module yet. I've got to come up with a suitable preamp. Basically, you've probably figured it out by now what I'm doing. I'm building another amplifier in a case. So look out for that project. Once I've got the preamp all designed, I'll do a separate video on that. Yeah, but for now, there's not much more to say about this other than it works. So yeah, anyway, I'm the Astro 30, and if you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Anyway, this is the Astro 30 saying, see ya, have a great day.